Well, why don't we get started? Good morning, good afternoon, everyone. Thank you so much for joining our webinar. We're going to talk about what the opportunities are that we see in the life science tools and diagnostics space today. I'm very excited because we have a special guest in this webinar today. And so I want to share with you that we're going to be doing a quick introduction and then talking about the market trends. And our friend and partner from DeciBio is here to share that piece of it. And then I will be talking a little bit more about the perceptions that we see in the lab, so a little bit more on the ground, and then we can synthesize and have a discussion. So again, as I mentioned, I'm very excited to have DeciBio partner with us on this webinar. DeciBio is our go-to partner for many of our clients who need either looking at market trends or doing an analysis for the market future. And I couldn't think of a better person to join in this particular topic than Stephane.
Hi everyone, I'm Stephane Budel. I'm a partner at DeciBio. I have a technical background, a PhD in neuroscience and 15 years of experience in management consulting, first at LEK and then at DeciBio, where I specialize on disruptive technologies and how they can be implemented in precision medicine and by biopharma or clinical customers. And similarly, Hamid, great to be here. And we feel the same way about your firm. Like we send everyone we can whenever they need help with marketing and branding.
Thank you. Thanks very much. So I'm Hamid Ghanadan. I'm the CEO of LINUS. And as Stephane mentioned, LINUS is a strategy and an innovation firm, really very much focused on insights. And we work on commercialization issues, marketing, branding, product launches, and so on. But one of the other things that we do is to take a pulse of the industry on an ongoing basis. So we look at what's happening sort of on an individual level every 6 months. The economy, one of the key things that you look at the economy when you hear reports about the economy is consumer sentiment. Because consumer sentiment really is a great predictor for how people are thinking, what they're planning on doing, and it's a great predictor for their actions. And the actions can also mean sales. And there is no such data point in the life sciences for the customers who work in a lab every day, whether in tools and then the tools and diagnostics providers. Really, we felt could benefit from this kind of consumer sentiment data. So we started taking this data every 6 months, and I'm happy to share this with you after we walk through Stephane's insights about the market trend overall. Just one quick housekeeping note before I turn it over to Stephane. If you have questions during either of our presentations or our discussions, there's a Q&A panel. Please just type in your question and we will stop at salient points and read them and discuss them. So we're looking forward to a great conversation with you in the next hour. Okay, Stephane, I want to turn it over to you to talk about some market trends.
Perfect. So starting with the first slide here, what we show, it is actually a slide for our introduction deck for the new people who come and work at our firm, like the new analysts and associates. And our mission is to help accelerate the adoption of precision medicine technologies. And the point we're trying to make here, and one of the reasons why I think a lot of us are in this space, is that diagnostic can be as powerful a tool as therapeutics, as exemplified best in early cancer detection, ECD. So what you see on this graph right here on the x-axis, you essentially have the patient journey and the role that diagnostic and therapeutics can play. So you can see, like, starting with screening, you then go to diagnosis, then treatment, then monitoring. And again, diagnosis really actually, diagnostic tools play a role in each one of these 4 steps of the patient journey, as in contrast to therapeutics, which actually is during treatment and monitoring, as you can actually switch therapies. So now looking at the graph under it, one point that we're trying to make here is that the prognosis for a cancer patient actually ties much more to the stage of diagnosis than it does the therapy that person goes under. So again, on the left-hand side, if you look at the green dots, it shows you what is the 5-year survival rate by different by stage of different patients with different type of cancers like prostate, breast, etc. And as you can see, the green dots, the survival rates are anywhere between 30, 35%, and 100% in the case of prostate cancer. Now, in very sharp contrast, as soon as the cancer starts to metastasize and you look at the red dots, you have this massive shift in survival, and now the survival rates are closer to the 5 to 20%, 30% rate, right? Now, if you look at lung cancer in particular, and you actually look at like one of the the red dot on that graph, like the metastatic lung cancer, Jim Allison got the Nobel Prize in 2018 for the work that he did looking at, PD-L1 and PD-1, essentially realizing that checkpoint inhibitors and a subset of these checkpoint inhibitors can actually get used to treat cancer patients. And what you can see is the way that this thing that actually warranted someone getting the Nobel Prize actually only shifted the survival rate a tad compared to what was the chemo standard of care at the time. So clearly, you want to be on the left-hand side to win the war on cancer, although both therapies and diagnostic can play a role. So this is really the reason why we think that tools and diagnostics are important, and I think the reason why we are pushing for this industry to get more recognition. Looking at the next slide, one point that we're going to make here is that if you look over the last 2 decades, one thing that happened, which has been completely incredible, is that a number of tools companies, like we're talking about the Thermo Fisher, Illuminas of the world, have been developing solutions that really enable logarithmic growth in data sets. So back in 2014, when Illumina came out with the HiSeq X, you had to purchase 10 instruments, and that enabled you to generate 1.8 terabytes per run, which was actually incredible on this 10 platform. Now, today, if you get a NovaSeq X or you get a Promethean platform, you can generate 8 terabytes of data or 14 terabytes of data, respectively. So this is really incredible, like the amount of information that you can get. If you look on the right-hand side, on the proteomic side, the same is true. There is like hundreds of terabytes of information that can be generated and that have been stored in databases such as Pride, for example. Now, in response to that, there is a number of efforts, such as the Beyond 1 Million Genome Project, that aim at finding ways to make sense of that data and actually trying to share it in ways that is actually much more straightforward. Now, one point that's interesting, and for some of you who listen to the Lex Friedman podcast, he recently had Mark Anderson as a guest. And Mark made the point on that podcast 2 weeks ago that the big shift that happened in tech used to be that it used to be a tools industry. Like PCs and smartphones used to make all of the money. But since like 2010, most of the big wins have actually been in the application, like Uber and Airbnb and Lyft, etc. And in the future, most of the money will actually be in apps as opposed to the tools. And the analogy here is that if you do believe that biotech is on that big tech type of track, what it means is that in the future, you're going to have some kind of consolidation equivalent to what we see in the tech world, where you have this magnificent 7. And you can see the name in the footnote. It's Apple, Microsoft, NVIDIA, Amazon, Meta, Tesla, and Alphabet. So you have like this set of large companies who actually benefit so much from their scale because of a network effect that happens, that it becomes extremely hard for competitors to find a way in. So it's likely that, again, if biotech is on that track, which we believe it is, data sets are going to become more important. As data sets become more important, collecting the data, curating this data become much more of a competitive advantage. You benefit from a network effect. And as a result, time to entry and being early to market matters more and more. So if you look at the next slide, there is an additional point that we want to make on how much this data is actually scaling. If you think of genomics, it is actually largely digital of a technology. And what we mean by that is ones and zeros, right? ATGCs. And sure, the purists will say like, well, actually DNA can form in 3D and in space and influence each other, but it's largely digital. Now, in contrast, proteomics is actually analog. Like you have proteins that have like 20 amino acids, obviously, it falls into space, they interact with each other. So the level of complexity when you work with proteins, as opposed to the genome, is exponentially larger. And actually right now, what we're doing with spatial omics, which is like the latest trends and generates so much hype right now, is that you actually can look at both genomic and proteomics information in space. And so the amount of information that you get from a single experiment is just completely staggering. We're talking about a single experiment generating more than 100x the amount of information that you get from an whole genome sequencing data. So clearly there is like this massive need to actually make sense of this information as we continue to actually collect it in a way that's not only logarithmic, but actually geometric. And what I mean by that is that actually it looks logarithmic on a log scale. So you have this exponential curve on the log scale, like the data complexity is growing in a way that's actually really hard to comprehend. If you look at the next slide, flying through them, one thing that has been interesting that has been happening is that you see that these tools and technologies that actually have been developed over the last couple of decades are in turn starting to get used by diagnostic companies in order to develop increasingly complex diagnostic tests that are being used for, again, in this case of this example, like cancer testing. Again, we're looking at the patient journey. You have early detection, therapy selection for tissue and blood, MRD monitoring, and real-world data and evidence. So this is a data set that I think is about 6 months old. So the field actually moves really rapidly. But what you see is on the x-axis, a number of logos of these companies, or the y-axis, I should say, of these companies that are developing all of these tests in order to, that are like extremely complex, again, in nature, that tend to rely on NGS, but also multiomics and other technologies in order to actually help with patient cares at different stages of the journey. The second point that we're trying to make here is that if you actually look at the green cells, those are the tests that are FDA approved. So not only are these tests being developed, but they're actually increasingly developed and validated with like an additional level of scrutiny that actually warrants like easier reimbursements and as a result, like easier adoption from a variety of stakeholders beyond just academic medical centers in the US, but also in community settings. So really, again, the point being made here is that you see these technologies not only getting used in academic lab, but that being actually translated, and this vast amount of information actually getting translated into databases and into clinical settings for patient decision-making. If we go to the next slide, one point that we're making, and again, this is one of the key points from this talk, is that if there is one thing that you remember is that we do believe that this is going to lead to some form of consolidation in this market. And this trend is actually accelerating. And if you look on the left-hand side, you essentially have what happens for some of these large players that actually manage to get all of these data sets. So there should probably be an arrow that actually gets started to fuel this wheel into new samples being sent to a company like, let's say, Foundation Medicine or Caris or Tempus, but those are just illustrative names. And these new samples actually come in. So it actually grows the database. As the database actually grows, it enables you to actually understand like more and more complex type of signatures that are not simply just dependent on a single allele, but for example, like tumor TMB is an example of something that you can get as you actually start to get more and more samples. As a result of these novel targets and signatures, you have increased value of the database that enables you to now sell this data and information as real-world data and real-world evidence to biopharma customers. That gives credibility to this whole set of database to actually now getting additional customers to actually be using the database. So you have this virtuous workflow of additional samples being used and the successful players essentially continuing to grow rapidly. Now, on the right-hand side, what happens with startup is that we see that for them, there are really 3 paths forwards, right? And it's essentially get acquired, differentiate, or die. Those are like your 3 options. Like as a startup, if you differentiate, a lot of time what that means is that you're going to have to go after markets that are not necessarily some of the biggest ones, but you want to go after a niche market, for example. One of the recent examples that we've been talking about a lot with our clients recently is how, in the case of MRD, what you see is the large players like Ghanadan and Natera going after some of the key indications like in lung, CRC, and breast, because this is really the largest market. But the reality is that there are like a battery of other type of indications. And if you think of all of the different type of use cases that you can use monitoring for, it's actually a bunch of like indication and a bunch of use cases. So you have this massive matrix where each of the cells represent an opportunity, for example, for someone to be going after bladder cancer for a specific use case at a specific stage of a patient diagnosis. So really something that is important for this startup to be able to compete successfully, because if they were to go after something like breast cancer or colorectal cancer, where companies like Natera have so much clinical evidence and so much data, makes it very difficult for them to compete. So moving on to the next slide, one thing that we try to think is that if we try to communicate that time to market really matters and time to market is really important, we need to try to think about what are some of the tactics that can help you accelerate development or accelerate time to market. And so we come up here on this slide with 5 different types of alternative or tactics in order to do so. The first one would be partnerships with pharma, if you start at nude on this graph. And a lot of time, this partnership actually works as fee-for-services, where it gives the technology credibility. It also enables you to understand customer needs. As you work with pharma, they can actually tell you, this is really like the type of data that we're looking for. And it enables you to continue to perfect your product before you give it like a commercial launch, for example, in clinical settings, as opposed to offering it as a service to biopharma. So that's number one. Number two, and in the same vein, you can actually try to have early access programs. And that could be either via like having some alpha or beta units, or as a service. And one of the beauty of this is that it can actually help you stall some of your competitors and work with customers collaboratively to refine product, service, and specification. Again, this idea of stalling the competitors is that if you have someone in the market who already has a product, but you can come in to our customers and tell them like, oh, by the way, we'd like you to actually try this as a service, or we're going to place a unit in your lab, it might be enough for them to actually pause and wait before they actually purchase something from your competitors, because they actually get a feel and a sense about what your platform might do in the future. And before they commit to the first one, they actually could kick the tires on use. The third one is KOL, or key opinion leader collaborations. And so they can lead to publication in high-profile journals, obviously, and presentation at key conferences such as AGBT. You all probably know the name of some of the KOLs that tend to be having these keynote spots at these conferences, like things such as people such as Chris Mason, for example, come to mind. And these people actually have many people who attract very good people in their lab. They tend to be very prolific, publish a lot, and again, they tend to actually be able to publish something 1 or 2 years following adoption of the technology, which is quite different from my own experience in the lab, where it would take me 3 to 5 years in order to publish what I'm working on. The fourth one would be collaboration on data sets. And the idea here would be to try to identify who may be good collaborators that you can work with, and that you may have a genomic data set, they may have a proteomics data set. Is there a way to, for example, to marry these two data sets? Or similarly, they may have some kind of outcome data, and you have genomics data. If you look at the relationship that data exists between Regeneron and I'm blanking down on the name of that company in Philadelphia, but in Pennsylvania. But there's like a number of collaborations that can be made where you can offer a service and someone else can offer this, like the sequencing, for example. The last one that we have here is optimizing bioinformatics workflow. And the reason that this is important is that it can also help accelerate the experimental pace of your customers. I will give you one very specific example. In the case of the spatial omics, when the Hyperion launched from Fluidigm, there was so much data that was being generated from reading a single slide that it would literally take months for people to actually be analyzing the data, making sense of it before they would run another experiment. So as a result, the sample volume was actually relatively slow, and like the reagent pull-through on this platform was actually relatively low, simply because it would take so long for people to make sense of the data. So interestingly enough, the bioinformatics can really help you essentially accelerate reagent pull-through to its peak. I think the last point that we're making here as a sub-bullet is that these databases of omics information can identify actionable signatures that can have, it can obviously have a positive feedback loop. When people identify signatures, they're complex, and as a result, they're going to have to use your technology as opposed to another one that is, for example, deplexed in order to get to the right answer. So if you look at the next slide and the last slide before I pass it on to Hamid, what we think is important here is that although speed to market matters, we have to be very conscious of what are some of the hurdles associated with large data sets. And what we mean by that is making sure that you don't rush to market with a product that's essentially not ready and that can face a number of key issues, such as the 5 that we list here. The first one, actually, lack of reproducibility, is something that we heard in the past, but that, again, I believe Hamid will talk about some more in a little bit. When you look, somewhere between 65 to 90%, the typical number of people use is 80% of the academic literature is just not reproducible. It's actually due to a mix of factors that there is biological variability, technological accuracy, there's imprecise protocols that people publish. And sometimes when you talk to people, especially in academia, they will tell you that you just switch an antibody batch and that's enough for your experiments to fail. it's actually, I've even heard some people say sometimes you change the water, the distilled water that you use, and that's enough for like a PCR reaction to stop working. The second one, and again, I believe Hamid will be talking about it some more, is lack of bioinformatics support. And we talked about that earlier a bit, but it's important as you have like increasingly complex data set to make sure that you offer solutions that enable people to make sense of the data. It used to be that people did not want to pay for bioinformatics, but it's actually luckily changing. Like in the past, NIH was funding so many bioinformaticians in order to develop essentially freeware for people to make sense of bioinformatics, to make sense of like that genomics data, that it was really hard for people justifying actually paying for a bioinformatics tool. But luckily, this is changing because the data complexity is so high that these commercial vendors now have a set of value that's actually easier to articulate. Third one is high cost. Like as you have a drop in analytical cost, you have to keep in mind that people not only think about like how much it costs me to sequence a genome, for example, just to stay on a genomic theme, where it's like now for $200, you can actually allegedly sequence a genome. But the reality is that we're nowhere close to that number when you actually think about the fully baked in cost of analyzing a genome with the bioinformatics in the backend. The fourth one is lack of data integration, and we touched on that already a little bit. But again, this idea is that once you actually have genomics data set and proteomics data set, how is it that you can actually marry these two data sets in a way that actually makes sense? One thing that's interesting is that multi-omics is something that I first heard about probably close to 20 years ago now, actually. And at the time, people thought about it and they didn't really have a good case, right? And the term that I had heard used in the past is circus trick. It's like, it's a cute trick that you can do, but now that has changed. With liquid biopsies and spatial omics, you can actually now demonstrate that there is real value in capturing this multi-omics information in a way that is completely enabling. That is not you simply do it because you can, but you do it because if you don't, you can get to the right answer. And finally, there are concerns with data privacy. As genomics data become more easily accessible and actionable, it's important to have firewall, secure cloud-based servers, and in different geographic locations. It's certainly very true in Europe, where the GDPR laws are actually very strict. It's obviously true in the US as well with HIPAA. So making sure that you appropriately consent and protect patient information is more critical than ever. So again, try to get to market quickly, but keep in mind that as you actually generate this information that and all of these large data sets, you have to make sure that you address some of the key pain points listed on this slide that come along with it. So this is it in terms of the key points that I want to make initially. So I'll turn it back to Hamid for now and see if there are any questions or if you just want to move forward with your section.
Stephane, thank you so much. That was so good. Obviously you and I have talked about this before, but a couple of points that you made that really hit home for me. Number one, I mean, for as long as I remember, the message, the overarching message to biopharma or pharma has been like, go faster, go faster, go faster, right? But what you're talking about and the new lens that you put into this is really salient in that this is right now, we're living an inflection point where it's not just go faster, go faster, go faster. It's all about the data set. It's essentially get the data set, as fast as you can for a variety of the reasons that you just talked about. And so that connects these 5 things that are on this slide, the reproducibility. If you don't have clean reproducible data sets, that data set's not worth a lot. And then the other point I wanted to make was, the bioinformatics. I completely support what you said with respect to making sure that there's bioinformatics solutions. And for anybody who's on the call or is going to listen to this, that is in the either a product management or a product development role, well, we're actually starting to see, and this is also the case in other industries and other tech industries. It used to be that the instrument basically created it was all about basically isolating and then teasing out the signal and then making the signal, and then there was software that made the bioinformatics happen and make meaning out of it. But what we're seeing actually in the life sciences is that these actual instruments have bioinformatics designed on board. And so, many of these analyses are now sort of chip-based. And the way that chip is designed with the idea of the information and the knowledge you want to get out of it. And so the bioinformatics is really built on board. Another example is, the new HiFi instrument from PacBio, for example. Not only it has 4 NVIDIA chips, but it also has Google Health running on board. And so it's really meant to reduce or even eliminate, you know, the lengthy bioinformatics support that then drives the high costs, drives the you know, all the other things that you talked about. So this was really brilliant.
And I would say, like, on your comment, I think you synthesized it really well. And again, like the key point for listeners here that we're trying to make is, again, this analogy of the network effect that happens. Think about Facebook and Instagram. Once you actually are number one and you actually have a network, people automatically are going to come to you. And it's likely that the same is going to happen in tools and diagnostics, that like it becomes important as you have increasingly large data sets. If there is this analogy of the network effect based on the data set or based on like the number of people who use the platform.
Yeah.
Between so that's I think one of the message here.
Yeah. So not only are not only is the tools and diagnostics you know, suppliers, clients and customers are in the race for the data set. The tools and diagnostics providers themselves could be in an arms race for clean data sets, and then new business opportunities will open up. Correct?
Agreed. Yes.
Yeah. Excellent. Well, thank you again for that. And just a reminder to our audience, if you have questions, please type them into the Q&A and we'll address them. So I'm going to take you now onto a little bit of a sort of a personal view of what's happening within life sciences. And so again, as I mentioned at the top, we do a survey once every 6 months. And this time we talked to 575 scientists across the world, where we invited them to take a 10-minute survey. And we asked them a variety of questions that I'll share with you. And then we also followed that up in parallel with 15 in-depth one-on-one conversations so that we can get a lot of good texture as far as what's going on and how people are feeling. 5 key takeaways from this particular set. So just for you to know, this data set was completed at the end of May 2023. So it's about a month old. And so we asked them questions about recession, about how they're feeling about science moving forward, what are the big barriers that they're facing, what they're planning on doing about it, what kind of technologies they're interested in buying, and where they're going just generally with their work. So number one, recession fears are still there, but they're not as significant as they were in January when we took the first survey. So and I'll share that with you in just a little bit. So recession fears are starting to recede, and that makes a huge difference on consumer sentiment and consumer behavior. The second one is that there's these key indicators that really suggest that scientists are pretty optimistic about their future and about the progress that they're making, and they have really high expectations about their progress, even in the next 6 months or the year ahead. And this is in large part driven by 2 shifts that have happened. One is automation, or the desire to move to a next level of automation, and the second one is AI. And the integration of AI into into what they're doing. Zooming in a little bit about biopharma. Biopharma is really focusing on seeking efficiency. Again, very much through automation and AI, but through other facets, and they're really looking for how to be smart about their work and as efficient as possible. So those are the signals that we received. So this is really a technology story around automation and AI. It's a labor story, which you'll see, and it's a data set story, which will support what Stephane just talked to you about. So again, just at a high level, it's people aren't really proliferating projects anymore because cash is not free and it's not as readily accessible. Cash now costs 5 cents for every dollar, or whatever the interest rate is. But the scientists that we talked to and who answered our survey, they're continuing to build on and invest in the projects that they care about. And so we're looking into that. Some key indicators, like I mentioned, the recession fears, that sort of the economy is headed into recession, receded by 7 points. So from about 1 out of every 3 to just over, just about 29% are thinking that recession is going to negatively impact their work. But over 50% of our respondents actually still say that they're prioritizing adopting new technologies this year, making new technology purchases this year. This is always a cyclical number. At the beginning of the year, this number is usually in the 60s. And then mid-year, it drops significantly because many people have already made technology purchases at the beginning of the year and are now, getting them online and using them and taking data. And so there's mixed news here a little bit, because what we usually see and what we saw in 2022 is that at the beginning of the year, about 67% of the people said that they were planning on purchasing technology. Mid-year, that number was 32%. So sort of normal. We asked them why and so on. Now, beginning of the year, it was 68%. Now it's 53%. And so that means that there's a lot of pent-up demand still for the second half of the year. This may be because people were waiting to see what happens. And we've heard that from a lot of our clients saying, you know what? The customer has the budget. The customer approved the purchase, but they didn't pull the trigger. Why? We have no idea. Consumer sentiment. That's what's driving this sort of this apathy or this angst in making big purchases. But we see that the purse strings are starting to loosen, and over 50% are still prioritizing that. 40% of the people in pharma and biopharma say that increasing automation is a top priority for the year. So that's where they're moving in that direction. And then 44% of the ones who are in Asia Pacific are expecting economic growth in the second half of 2023. So, and when we say Asia Pacific, most people think of China. We're actually thinking of India here, because India, as the government is putting a lot of money toward biotech and moving that forward. Okay, so asking about what the top barriers are in life sciences, in this year, we see here that economic recession, headed into recession, fell to number 2, from being number 1 in January or the beginning of the year. But reproducibility issues with experimental results actually is number 1. So Stephane, you alluded to this. It's a big problem. This is when I don't see reproducibility on top, I think, okay, we're away from science and other things are driving things. When I see reproducibility on top as an issue, we're like, okay, we're returning back to science, because that's the main issue in science right now. But look at number 3, 4, and 5, very much tied to this: untrustworthy information in published papers, otherwise known as reproducibility issues. Complex bioinformatics or analysis. We just talked about that, and we heard from Stephane about that. And then lack of standardization of protocols, again, which is probably at least a factor in the reproducibility issues. But the last one I just want to mention, if the name of the game is data sets, standardization really is the de rigueur needs to happen, absolutely. Because if I get a data set and I don't have really clean metadata and I don't have the provenance for that data set, it's pretty much useless to me. And so the standardization of protocols is something that's moving forward as well. So tools and diagnostics providers think about this as a way of increasing your value proposition by making those, your protocols the standard ones. Scientists actually are so fed up with reproducibility that they're willing to open up their wallets for it. And so, again, top barrier, 1 in 3 scientists say that this is an issue. And, especially in pharma and biopharma, I just want to focus in on that quote at the bottom that says, 100% I would pay extra for this solution. And I know a lot of people who would. There's a lot of frustration to figure these things out. So we as suppliers actually have an opportunity here to give better characterization, more transparency in the materials, the products, the reagents, and the kits that we provide. And we think that there's going to be a hunger for this, as science sort of reaches that boiling point where trust is being eroded in the numbers. Stephane made a great point about, like, you change the water, qPCR stops working. There's something in the water. So, we asked another question about what they're thinking about doing as far as their own top 3 priorities. So we first asked, what are the big things that are going to make a big difference in science in general? And then we say, what are you doing? And we compare the difference. A couple of really interesting movements in this particular time point. So obviously, you see adopting new techniques to acquire new types of data is number 1. Over half of our respondents, that's their top priority. And then following, finding new collaborators. This is for essentially being able to access other data sets. So, that's also part of, finding new collaborators. It's expertise in data sets. But look at number 3, adopting machine learning or AI became the third one for the first time that we've ever taken this survey. In the past, when we asked what's going to make a big difference in science, AI and ML was up there. But then when we asked, what are you doing in the next 6 months? AI and ML didn't really reach the top 5. Here it is in number 3. And so for the first time, what they think is shiny and new and what they're planning on doing about it actually aligns. And so this is the moment where, a lot of scientists are not sort of sitting by the sidelines to see whether and how to adopt AI. I have, a couple more slides on this in just a minute. And then, following from there, recruiting more scientists or engineers. So 23%, that's up significantly from January. And then recruiting more high-skilled colleagues who are not scientists or engineers also rose by about 6 points since our beginning of the year data. So remember, this is an AI story and this is a labor story, and automation is really the crosshairs through which I think a lot of the scientists are going to act through this. Again, zooming in on biopharma and pharma alone, it's all about working smarter. So 48% say that they're looking for new techniques to acquire new types of data, but 40% are automating more techniques and processes, and then 38% are actively adopting ML or AI. Automating more techniques and processes, there's an efficiency angle to it, but then there's also a standardization angle to it too. So to Stephane's point about that 5th point about, standardizing protocols and making sure that there's clean sort of data sets. We think that automation also, plays that, two-headed role here. So it's all about productivity in science, but people define productivity in different ways. So we ask them how they define productivity, but then we ask them, how confident are you that you're going to meet your productivity goals in 2023? And here we see this graph is fairly confident. You see that everything that is in some sort of shade of yellow or orange is high, very high, or even certain. And then that giant gray is moderate confidence, which is okay. It's a little negative if you were to put your put sort of NPS score kind of analysis on this. And the low single digits of people are not confident in their ability to meet their intentions for the year. That's a really positive note because, recession or not, these people are going to make what they promised or what they envisioned as what they were doing. So here's a quote from a research director in a biopharma company. They said, "We need to get more focused and more efficient on delivering key data sets. In the next year or two will be more exponential." So again, this quote serves the point that Stephane was making beautifully as well. We asked them, of those 53% who said that they're planning on making major purchase intentions, we asked them in an open box, what are you planning on buying? And here you see that 14% say that they want to buy a sequencer, 11% are some sort of an automated system, but 10% named some sort of AI. Again, first time we've seen this in any of our data sets. So it's truly moving into, that they're not ignoring it. They're not able to ignore it anymore. The signals are very clear and there. But AI, just implementing some software or some solutions is actually the beginning of a journey. And in fact, this to me is the money slide. 22% of those in biopharma and pharma, they say that they have limited or lack clean training sets for ML or data or AI. That's one of their top 3 barriers. So you get AI, it's an algorithm. You need to train that thing, and you need to make sure that you have clean data sets so that your machine learning algorithm or your AI algorithm can learn to disambiguate between one state or another. And because of reproducibility, because of complex bioinformatics and so on. And because that they're actually many times in biopharma, they're doing live biology, which is a lot more complex. These training data sets don't exist. And we think that this is a great opportunity for the tools and diagnostics providers who actually may be able to pivot or supplement your business models by solving this problem. So the more AI, the more there's interest in AI, there's going to be more interest in data sets that will train it, and then farther down, more interest in data sets that will help the AI make disambiguated calls. So we also ask about the recession. We wanted to zero in on exactly how these respondents are feeling, because again, if I feel like there's a recession coming, that changes my purchase intentions, it changes my behavior. Maybe I don't want to buy that new bicycle right now or whatever it is. And that actually translates to the lab as well. Maybe they don't sign contracts, maybe they don't buy instruments. And we have definitely heard anecdotes from our clients that says the budget's there, it got approved on a department level, they didn't pull the trigger for no reason at all. This is the reason. So you can see here that there's some people are actually anticipating growth. So about a quarter of the people are anticipating growth. 23% are saying it's going to be stable. And the remainder, who are about 51%, are saying that there's going to be some sort of recession in the next 6 months. Okay, so they're kind of preparing for that and moving forward from there. But here's where it gets really interesting. We asked them, what is actually driving your perception? Like, where are you getting this information from? And what's making you think that there's going to be a recession or growth? So of the 33% who are expecting, economic growth, either really strong or mild in Q3 or Q4, 33% say industry news about growth or profits, but 23% say they've been given authorization to increase their expenditure, and 15% say that they've already received higher budgets or funding. Okay, so these are people who are basically replying based on facts that have happened. Now look at the people who are fearing a recession. So of the people who are fearing a recession, 27% in academia, general finance or stock market news. So they're just basically afraid because they're hearing it on CNN or they're hearing it on their favorite news show that there's going to be recession coming. 18% industry news about layoffs. So not that layoffs have happened, but they've heard about layoffs, and so they think that the recession coming. In biopharma, 27% say that they've been given guidance to tighten their own expenditure. So this is a little bit more well-founded on guidance that they've given. But then another 25% say general finance or stock market news, and 18% say that they know other people who've been affected by budget cuts. So again, a lot of the recession fears are through inference and through sort of societal discourse, whereas a lot of the growth factors are from grounded, getting information and saying basically that they've been given authority to spend more money. That to us was really critical and really interesting. This is perception, my friends. If you're in sales or marketing, this is your finest hour. This is when you can overcome or work with those perceptions in order to get things on to your favor. So again, we also asked them these are the people who are specifically in business roles, and we're asking them, what kind of expectations do you have about budgets? So you can see here clearly that budget increases are more the norm than budget decreases, with 16% saying that they're staying the same. So, and when we average this out, the average can be telling. There's an average of 12% increase in budget across these decision makers. So that outpaces inflation. So, last time we did this, the number was plus 4.4%, but it was still lagging inflation, which means that their budgets, their actual spending power was going down. Now their spending power is going up. And we see this also between academia and biopharma, where academia is looking at more stability, biopharma is looking at more slight increases, or even between 10 and 25 increases, and so on. The decrease also happens. The slight decrease happens a little bit more on the biopharma versus the on academia versus biopharma. So overall more stable, maybe a little bit lower on academia, potentially higher on pharma and biopharma. And this was actually everybody who answered the question. One last point. So we talk about a lot of major technology purchases, but we also want to know what's sort of the run rate within the lab. So we ask about their everyday lab purchases as well. So reagents, chemicals, consumables, everyday lab products. What's going to happen in the next 6 months? So here's where we wanted to find out whether the supply chain issues from 2022 are still creating a backlog for the tools and diagnostics providers. Because what happened in 2022 was lots of overstock because there were supply shortages. And then they stopped buying because they were working through their inventory. Here we see that people are looking to stay the same, or actually increasing their purchases of these kinds of everyday lab chemicals, which means that they're actually cranking through those automation machines are working, and there's juice being pipetted back and forth and so on. And then finally, what's also interesting is that when you break it out by specialty, we saw a huge range of people who are planning on making major technology purchases. So of the list that's here, it was at least 66% of the people said that they were planning on making major technology purchases. So molecular diagnostics and pathology was at the top, developmental biology and so on. And then there was maybe another 10 or 11 specialties, which are below that 66% average of number, all the way down to only 40%. So, the money's there, the purchase intention's there, you have to know where to look. Just very quickly, the key takeaways, the consumer sentiment, predicting economic outlooks is hard, but scientists are bullish about their productivity. And so that means that they're not waiting for economic clarity to move forward. That may have passed. So that sort of, freeze mode may have passed. And then, again, efficiency is the new superpower for your customer. And the race for data sets, as Stephane mentioned, is also very much there. And then finally, we can't just look at averages. We can't say, 53% are planning on buying, because that number ranged from as high as 87% down to 40% when you look at different kinds of, specialties that people are in. So that's what I wanted to share with you. That's and I'm so glad that Stephane was here to talk with me about it. I see that we have about 12 minutes left, and we have several questions. So let's actually answer these live, Stephane. How do you feel about that?
Yeah, this is great. I think the first one, if you want to go to slide 19, I think one of the first questions that came up was around any concern with regard to shortage of labor or skills gap, right? And I think you addressed this on this slide, but I was wondering if you could, maybe elaborate on what type of skills are lacking, or what is it that people are actually, looking for, and do you see this shortage of labor? This is certainly something that we hear in our research, that it's getting harder and harder to get the trained technicians to be running complex instruments.
Yeah, so absolutely, that trained technicians to run more. We believe that people with expertise in digital transformation. So, you know what the number one sought out role is right now anywhere? It's an operations researcher in any industry. And that means that they're looking for someone to come in and essentially look at all their processes and find out where AI can either make them, accelerated times, or they can, reduce inefficiencies. That's basically what the drive is, and that's one of the two major axes of technology adoption and technology maturity. So we think that's really where the labor, focus is going to be. But also technicians and automations. Anybody who has automation. It used to be like 5-6 years ago, if you had CRISPR on your resume, you were guaranteed a job. Now it's like if you have automation or AI on your resume, you're guaranteed a job. So we think that that's really where things are going.
Yeah, that makes perfect sense, and that mirrors really much what we hear on our side as well. And we hear some people saying that one of the challenge when you adopt a new technology that may have novel workflows is that, well, we're going to have to train someone and make sure that this person sticks around. Because if someone comes, it takes 6 to 12 months to train them, and then they leave, then we stranded with that machine that nobody knows how to use, and obviously you don't want that. So there are two related questions also around real-world data and data sets. The first one being, how does diagnostic companies approach this issue, and do they generate the information or not? And the second one is, I think, based on some information that you share, that 48% of biopharma is acquiring new data sets, and how is it that they get about actually getting this information, right? Do they actually generate it? Do they acquire it through collaboration, or do they actually purchase a database? So feel free to go first, and I'm happy to share my perspective on this as well.
Yeah, absolutely. So we're also aware of a lot of diagnostics companies really looking at that real world evidence. So we actually work with years ago, we worked with Flatiron Health to really help them, launch their real world evidence offering into the cancer market. It's a tough business because it's, so it used to be that publishing was the hardest business that there was, because you had two markets. You had the readers and then you had the advertisers. So you were in a two-sided market. In the real world evidence world, you have a three-sided market. You have the patients and the medical centers who are actually collecting that information. You've got the biopharma who wants to get that information, and then there's the institutions. So the diagnostics companies and so on. So you really are looking at a very complex and multifaceted market. I know many companies are on the path for this. I don't know too many that are like significantly, have realized. I certainly don't know of any drugs that have come out of that, but I do know that it's very active in that space right now.
Yeah, I would echo everything you said. I agree that we actually recently did a survey with key opinion leaders. It was actually only 12 KOL, so small n, but we asked them what was the return on investment that they felt was best in terms of what they invest in. Tools and diagnostics actually came all the way on top, like especially with genomics, and real world data and evidence actually came really low in terms of ROI for the reason that you just mentioned, which is it sounds good on paper, but in practice, it's difficult to implement. And the way diagnostic companies do that tends to be through some form of collaboration, like was the case with Tempus. When you look at what happened with FMI, I think that those are good case studies of companies that have done this well.
Yeah.
But the other point to make really quickly around real-world data and real-world evidence is that there are a lot of companies that claim that they have very large data sets that are extremely rich, but the reality when you double click is that they only have information for a subset or full information for a very small subset of samples, and then they don't necessarily always have the commercial rights to these data sets. So there is a lot of nuances in this market.
Yeah, absolutely. The second question around, where are biopharma acquiring these new types of data sets? It's actually all of the above that you mentioned, Stephane. So they're buying new instruments, they're standing up new tech stacks to be able to do new types of analysis. They're doing collaborations, they're gaining data. An interesting sub-point, there's a paper that was published in Cells Insights like last week. And it was done by a company called LabPair, they're a startup, really ingenious, where they actually quantified that there's $6 billion worth of unused samples or unpublished or unused data sets out in, I think, just academia. So like it's an incredible amount of money if you think about data sets sitting around, and there's just no like way to transact on those. There's no way to get those. So we think that there's a huge possibility to do that.
Yeah, I believe Carlos Bustamante, I believe UCSF or Stanford made a very similar point in the past, that there is a lot of opportunities for untapped data sets.
Yeah.
So the next question in the Q&A is around, what are your thoughts on what's holding companies back from buying and implementing new techniques faster, based on the survey response that you have that people prioritize and want to adopt new technologies?
Yeah, it's expertise. And I think it's the number one thing. Again, in any kind of sort of maturity, whether there's digital maturity or scientific maturity, you have two axes. You've got the technology capability and you have to have access to it, but you have to have the expertise to know how to implement that across the organization. So it's not just, oh, I know how to use AI, is I know how to transform this organization to be an AI-based. So it's a strategy, not just, oh, I've done it before. And so that's a key. It's sort of like, you're not looking for the best player, you're looking for the best coach. And that's the main difference. That's what I think is both in the short term and the long term holding these companies back from technology adoption. Any thoughts on that?
No, I would agree. And we have 5 minutes or less to go through the rest of the questions.
Let's get as many as we can.
The next question is, you mentioned the importance of optimized bioinformatics workflow to streamline internal R&D and help customers make sense of the data. But shouldn't diagnostic companies also be starting to prioritize the importance of using software to get visibility into real-time diagnostic usage and performance data, potentially by bundling bioinformatics at the point of sale of the diagnostics as opposed to the instruments? So any thoughts on that end?
I mean, I would say absolutely. you have regulatory issues with that, obviously. And so you have to be very diligent with what kind of software, what kind of informatics, who gets, the information and so on. But I think I'm just stating the obvious. And
yeah. And I would agree. And it kind of makes sense. You're actually starting to see more and more partnerships with like Sophia Genetics, for example, and others, trying to find ways where you have bioinformatics companies doing collaboration with Illumina or other companies to make sure that people can actually do the analysis on the sequences, for example. So I think it is critical because, again, making sense of the data is everything, and it also benefits the tools provider.
Mm-hmm.
Right.
Yeah.
So the next one is around, the next question is, I wonder if the AI trend is real. You mentioned previously that AI did not appear on the survey result, but now it's top 3. AI is not new. So what has changed in recent times? Ooh, I have some thoughts around this one.
Why don't you start?
So I think AI actually is relatively new. Of course, the term's been used for 30 years, but like it used to be like just a bunch of regression analysis run in parallel. What happened with large language models, and large language processing is actually quite transformative. And AI is really now actually becoming something that it was meant to be. And we're just at the beginning. And we're talking earlier, and I was mentioning this term like geometric growth. And AI is also another one of these things that's growing like geometrically in terms of the number of parameters that are getting used. So I think that, sure, AI has been around for a long time, but now there is something new that happened. I think it was probably 2017, 2018, when they actually start to use that thing called the transformer. And again, I'm not a specialist in the space, but where you can actually start to use the same set of AI tools for images versus text, et cetera, et cetera. And as a result, it's just completely catalyzed and transformed the space in a way that created some emerging capabilities that didn't exist before. So it's more than bioinformatics, which AI was in the past. Now it is actually, in my opinion, a form of actual artificial intelligence.
Yeah, I have nothing else to add to that other than just, the flashpoint that happened late last year and this year with GPT style, publicly available AI. I think it's just people now see the power and they can start to imagine what that might be for them in their own, in their own world. Another plug for some friends of ours in the Netherlands who have an AI tool called a mirrorthink.ai, just like ChatGPT, but it's specific for science. And if you try it, which is free, you'll immediately spot the difference, which is before it answers the question, it gives you a list of sources.
Oh, wow.
That's what makes it really powerful for science. So
great. There is a quick question with regard to imaging and imaging software and how it ranked in previous years in your survey. I do believe that it was towards the bottom. If I recall, just top of my head, I want to say it was like 5% of respondents in your survey. I don't know if you want to put it up, but do you recall what it was like in previous surveys?
I don't remember. We can definitely get back to you if you email us directly. We can definitely get back to you on that.
Okay, perfect. And I think we have one last question in 1 minute, which is great slide deck. I'm curious how this data breaks down between clinical and preclinical space. I don't know if it's something that you intend to do. Any comments there?
Yeah, so I mean, I actually only shared about 10% of the data set that we have. So if you have a need for looking at any particular segment or subsegment, we're more than happy to actually work with you and zero in on this. We did this work because we wanted our clients and others to help with what we're calling a strategy sprint, to help you all identify and optimize where to go after the money in the next 6 months. So that you can really maximize and be efficient in your commercial options. So if that's of interest, anybody, happy to chat offline about that.
Beautiful.
Excellent.
Top of the hour. We're done. Yep. So congratulations. Thanks again for having me as a guest. Hamid, if you want any closing thoughts?
No, not at all. I was just going to thank you, Stephane, for this. I was going to thank my team for the research that they did, and to all of our attendees for joining and staying for the full hour. This was a lot of fun.
Same.
Excellent.
Good to see everyone. Thank you.
Okay, bye.